Now the seventh question. From a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45° and 60° respectively. Find the height of the tower. Understood? That means here we have a building, okay, on the ground. So the building and this ground makes 90°. Okay, suppose this is the building, and according to the question, a transmission tower is fixed at the top of a 20-meter high building. That means the height of the building is given as 20 meter. And here a tower is placed. This is tower. And from a point on the ground, okay, the angle of elevation to the bottom of the tower and the top of the tower is given as 45° and 60° respectively. Okay, so suppose this is the point on the ground. So angle of elevation at the bottom of the tower, this is the tower, the bottom point, and from this point the angle of elevation to the top of the tower, and that is given as 60°, and bottom at this point angle of elevation is 45°. This angle is 45°. And what is asked? What will be the height of the tower? Okay, that means here we need to find out the height of the tower. This is the height of the tower. We have given the height of the building at which that tower is fixed. Okay, and also we have given the angle of elevation to the bottom and the top of the tower. It is clear, children? So this is the way to draw the figure. So read the question carefully and understand the meaning. Accordingly you can easily draw the figure. Okay, and we can name that figure as AB. AB is the tower and AC is that together the building and tower together. AC is the height and BC is the height of the building. And here is the point at which this angle of elevation is being counted. Okay, and according to the figure, the height of the tower is AB. Okay, this AB equal to, that is the height of the tower, is equal to AC minus BC. Okay, if you subtract this BC from so figure is clear, children? Okay, so here we need AB, that is the height of the tower, that is from the figure, that is AB. Okay, and that AB is equal to AC minus BC. Understood? That is height of the tower, AB equal to AC minus BC. Okay. And see, children, you can see here two right triangles. One is big right triangle ACD and BCD. See, here in BCD, the angle of elevation, this acute angle is 45. This is 90°. So what will be this angle? This angle will be 45 because angle is some property. So this will be a right angled isosceles triangle, which means that side opposite to equal angles are equal. So if this is 20 meter and this is DC also 20 meter, because this also make 45°. Okay. So we have now BC equal to DC, that is equal to 20 meter. Okay. And next step you can consider right triangle ACD. And here we need, see children, here from the figure, since AC and BC, that is equal to, that AC minus BC equal to the height of the tower. So we should get an expression for AC and BC. And AC is the side of the big right triangle and BC also the measurement is given. And if you know this AC, you will be getting the height of the tower. Okay, and for that here see children, if you are taking tan of 60, because we don't want this hypotenuse, so no need to take any ratio which include hypotenuse. Okay, so here either you can take tan or cot. So tan 60 equal to opposite side by adjacent. Adjacent side is given. Okay, and opposite side is AC with respect to this acute angle 60 degree. Its opposite side is AC, not BC. This whole, because we have considered the big right triangle ACD. Okay, so tan 60 degree equal to opposite AC by DC, and the value of tan 60 is root 3 equal to, okay, here AC should be splitted because we need AB alone, that is the height of the tower, and from the figure this AC is equal to AB plus BC, right? Instead of AC, AB plus AC, and DC equal to BC equal to 20. Understood? Since BC equal to DC, so you can substitute this BC as 20 because its value is given, measurement is given 20. So in this equation only one variable, that is the height of the tower. Okay, so the next is very simple, just cross multiply. 20 root 3 equal to AB plus 20. So in order to get AB, you can take this 20 to LHS. So 20 root 3 is already there, minus 20 equal to AB. Okay, and from these two terms 20 can be taken outside. So 20 into, okay, after taking 20 root 3, okay, minus 20 we have taken outside, so 20 into 1 is there, so 1 equal to AB. So this is the height of the tower, that is 20 into root 3 minus 1. It is clear children? Now the next question. Now the 8th question. A statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. This is a question. Okay, this is almost the same idea of the previous question. That means here we have a pedestal on the ground, okay, and upon this a statue is fixed. Suppose this is a statue. Okay, and see, I will mark with this ink, and this is the pedestal and this is the statue. Okay, and from a point on the ground, okay, from this point the angle of elevation of the top of the statue, that is given as angle of elevation of from the point to the top of the statue is given as 60 degree, and from the same point the angle of elevation of the top of the pedestal, this is the pedestal, so this is the pedestal, the top of the pedestal, or you can say the bottom of the statue, both are the correct. Okay, so from the top of the pedestal, in terms of pedestal, so this is the topmost point of the pedestal, and that is given as 45 degree. And what is asked? We have to find the height of the pedestal. That means this is the thing, this is the height of the pedestal. This is what we have to find out. And for that, as usual, we can name the triangle, name these points as triangle A, B, C and D. Okay, and see from the figure what is the AB, that the height of the pedestal is BC. Okay, that means that is the side of the right triangle BCD, and also you have to consider right triangle ACD, because we should get to that answer in terms of the sides of the right triangle BCD and the triangle ACD. Okay, and the another very important point is here the right triangle BCD is an isosceles right triangle. Why? Because this is 90 degree and this also 45 degree and this also 45 degree. Okay, that means here what is the length of BC, and that will be same as DC, because sides opposite to equal angles are equal, because this is an isosceles right triangle. These are the basic concepts you should have before you solve the problem. It is clear, children, how this figure can be drawn? Okay, and from this we have to find out the height of the pedestal, that is BC. Okay, so children, here let the height of the pedestal is BC and the height of the statue is AB. That all things you can write. Okay, I am writing very important steps only. So consider isosceles right triangle BCD. Okay, consider isosceles right triangle BCD. Okay, we have BC equal to DC and that is equal to, we don't know, that is we can take that as height of the pedestal H. That is a required thing. Okay, and in right triangle ACD, that is not isosceles because this acute angle is 60 degree. If it is 45 degree comes in a right triangle, so it will be an isosceles right triangle. Okay, so here we can write, we can take that tan of 60 degree because here there is no role for the hypotenuse. So here opposite side with the CD, that is tan of 60 degree, that is the angle of elevation from this point to the top of the statue, that is 60 degree. So that is in big right triangle, so AC divided by DC. And we can substitute, that is tan 60 is root 3 equal to AC. AC you can write in terms of AB plus BC. AB plus BC divided by DC. See children, here the height of the statue is given as 1.6 meter. Okay, so that you can substitute here that as 1.6 meter. And since this forms an isosceles right triangle, okay, so BC equal to CD. So actually in this equation, even if we have 3 variables, this is reduced into one single variable. Okay, let us see children. Here we can substitute as for AB as 1.6 because that value is given, the height of the statue, plus BC. BC is the required height of the pedestal and that we have seen that is also equal to DC. So you can write in place of DC as H because BC equal to DC equal to H we have taken. See children, how many variables? Only one variable, that is H, that is the required height of the pedestal. Okay, so by cross multiplying this one, H into root 3. So you will have H root 3, okay, equal to 1.6 plus H. I am taking that variable term to LHS. So H into root 3 minus H, when positive H come to LHS, minus H 1.6. So I am going to take H common. Root 3 minus 1 equal to 1.6. And from this step, H is equal to 1.6 divided by root 3 minus 1. Okay, so this is the height of the pedestal, that is H is equal to 1.6 divided by root 3 minus 1. This is an irrational number. Okay, when you subtract a natural number from the irrational number, that difference is also an irrational number. That means you have to rationalize. But here children, in this irrational number carries 2 terms. So you have to take its conjugate, that is if root 3 minus 1 you have to multiply with the irrational factor. Irrational factor, rationalization factor of this is you have to multiply with root 3 plus 1 divided by root 3 plus 1. If it has only one term in the denominator, we are multiplying and dividing with that same number. But if it carries 2 terms, okay, the irrational factor is rationalizing factor become root 3 plus 1 divided by root 3 plus 1. So you will be getting here 1.6 into root 3 plus 1. Here children, root 3 minus 1 into root 3 plus 1, a minus b into a plus b, that identity, that is a square minus b square. Root 3 whole square is 3. Root 3 whole square is 3 and 1 square is 1 itself. Okay, so 3 minus 1 is 2. The denominator now become 2. It is clear children. Here in place of a we have root 3 and its square you will have 3. So 3 minus 1 square is 1, so 2. And here 1.6 and 2 get cancelled. 2 in 1.6 is 0.8. So the height of the pedestal, that means BC, okay, that we have taken as H, okay, BC, H is equal to 0.8 into root 3 plus 1 meter. Calculation should be perfect. You have to solve this problem. Only you will be getting the full mark only when you getting that all the steps correctly. Okay, so here you have to rationalize using its correct conjugate, that is root 3 minus 1, 2 terms. So you have to multiply with root 3 plus 1 and divide with the same number, so that this the denominator become a rational number, so that this will cancel with 1.6 in 0.8. Okay, and root 3 plus 1 into root 3 plus 1. That irrational number can come in the denominator, but if it comes, that irrational number comes in the denominator, you have to rationalize. Okay, so this is all about this video. The remaining problems we will solve in the coming video.